What's up, guys, and what's up, Instagram? So again, today we're continuing the Khan Academy math problems, streaming live. So I'm going to solve these problems live for the first time, which is really fun. If you're on Instagram, make sure to go to my YouTube channel so you can actually see the screen share, see what I'm doing, as opposed to just watching me talk. But anyways, let's get started. Again, this is my last day at my parents' house. I'm leaving tomorrow. I might do one more video from here before I head out. And I was super sick yesterday. Don't know why. I think from my little niece's visit. I think maybe I got something from her, my sister, something. I don't know. But now I'm back. So sorry I missed yesterday, but we're back in action. Today, we are solving polynomial factors and graphs problems from Khan Academy. All right, so without further ado, let's jump on the screen share so you guys can see what it's all about. All right. And let's go here. And then we already got this one up on the whiteboard. Got it all set up. All right, let's begin. So it says p of x equals 2x cubed minus 18x. It says given the polynomial function defined above, what are its zeros? So to do something like this, again, factoring is a big theme of the SAT. Usually that's a lot of times you see something like this, factoring is going to be the first thing that you're going to want to jump in and do. So we've got 2x cubed minus 18x. And we can factor two things out of this guy. We can factor a 2 and an x because they're common of both terms. So that's what we're looking for. There's a 2. The 2 is common of both coefficients, 2 and 18, and x is common of x cubed and x. So we factor those guys out. What we have left here is x squared minus 9. Okay. Now we've done a good job here at factoring, but now we can go one step further. If you recognize that this piece right here is actually a difference of squares, meaning the first term and the second term are both perfect squares. The way you factor a difference of squares is you put it into two groups of parentheses like this. The first one is going to be the square root of the first term, x, plus the square root of the second term, 3. And the second binomial is going to be the square root of the first term, x, minus the square root of the second term, 3. So you see how this splits up? It's like this with anything. If we had x squared minus 16, it would become x plus 4, x minus 4. Okay, that's just the basic difference of squares. So now we factored this guy really nicely. And so now let's think about all the zeros, aka what are all the values of x that are going to send this entire expression to 0? Well, if this x here is 0, right? It sends it all to 0, so x equals 0. What else? For this binomial here, if x are negative 3, it would send it to 0. And for this last one, if x equals 3, the whole thing would go to 0. So we have our 3 zeros, negative, and if we write it in order from least to greatest, negative 3, 0, 3. And they put it in set notation kind of like this. There's your answer, D. So let's go ahead and input that over here. Hold on a second. We're going to go to this guy and to D, make sure that is correct. And it's good. All right, we're good to go. Let's do this next one here. Question number 2. And this one is involving a graph. You could say arguably sometimes these graphing problems can be a little bit trickier, but you never know. Let's take a look. Okay. Which of the following functions could represent the graph at left in the xy plane where y equals p of x? This is our function, this crazy curve thing here. So they want to know which one of the following could this be. Okay, so let me tell you the first truism of polynomial functions is that depending on the exponent, right? This function, as you can see, I'll put this in red, hits the x-axis 3 places, 1, 2, 3, meaning it has 3 zeros. And that's actually the most zeros that this function could have. So if this polynomial function has 3 zeros, it means that the greatest degree has to be at least 3. So these two answers, A and C, have x squared as the greatest degree, as the greatest exponent. Those impossible, can't be that. Now let's choose between B and D, right? They both have x cubed, and that's looking good. Now the question is, which one is right? Is it this one or this one? Okay. What I can tell, so let's see here. I'm trying to think about this for a second. Now let me factor these guys. So what's happening is the zeros here are in the negative, like negative x, but 0, negative x, and negative. In the bottom And so I'm trying to think which one of these would give us all negatives. I think the best way to do it is factor both of these guys. So I'm going to factor out an x first, and then we have x squared plus 6x plus 8. And if we were to factor this, and we get x times x plus 4 times x plus 2. And this is for b, right? So I've just factored that. This would give us 0 for this x out here, -4 for another 0, and -2, right? Because we're thinking again, what is going to make each one of these different pieces 0, right? So in this case, we actually have both negative zeros. This probably is right, B, but let's just double check with D just to make sure. So I'm going to factor out an x here like this, x squared minus 6x plus 8. And if we do this, it's going to be the opposite. It's going to be x times x minus 2. You see how I'm factoring this? X minus 4. These guys both have to be negative in order to get a -6 and a +8. That means we got a +2 and a +4 for these zeros and a 0 out here. But the zeros aren't positive, they're negative. D cannot be correct. Therefore, it's got to be B as we had originally thought. So let's give it a shot. See what we got. And yes, it is correct. All right, let's move on to number 3. Clear the board. And again, if you guys are watching on Instagram, don't forget, come to my YouTube channel right now. Go to YouTube, search for Scalar Learning. You can see the live stream. You can actually see the problems on my YouTube channel instead of just watching me sort of talk about these problems. So go to YouTube, search for Scalar Learning, and you can jump on right now and get in on the action. Even try these yourself. Okay, again, this is a no calculator problem. So it says a polynomial has zeros at -9, 2, and 0. Which of the following could be the polynomial? Let me show you how this works. This is how you can actually kind of figure this out. 3 zeros, okay? That means the degree is going to be x to the, x cubed. It's going to be the highest degree. A is immediately gone, right? We don't care. X squared is no good. Now, how do we figure this out a little bit further? My guess is actually this is going to be B, okay? But I can show you how we can actually figure this out. So again, if we factor a polynomial of degree 3, it's going to be like this. Let's pretend here's our 3 zeros, right? And the 3 zeros, the way you use each of these zeros is you're going to kind of plug it in like this, right? First of all, we have, it's like, you think about it like this. It's like if 0 is a 0, right, then one of these is going to give you, one of these expressions is going to give you 0 when just x is 0. So I'm putting in x minus 0. So when we plug in 0 for x, this term is going to go to 0. And that's what makes sense. That's what it means when it says this guy has a 0 at 0. The other one would be for 2, would be x minus 2. Why does this make sense? Because this means that at 2, this term is going to go to 0, making the whole thing 0. And then finally, we got -9. So we'd again do x minus -9, which this just turns into a plus minus negative, right? So now we've got that x minus 0, that's just x. So we can now simplify this to say it's x times x minus 2 times x plus 9. Now this is actually our answer, okay? But they don't have an answer in this form. Everything here has been sort of multiplied out. So now what we have to do in order to figure out our final answer, and again, I can tell you right off the bat, it has to be B, because there's no way that we can go from this to something with a constant with -18 or +18. But let's just multiply it out. Whatever, that's the process that I would follow just to be safe. So first, I'm going to probably actually FOIL these guys. I'm going to leave the x for the last. So if we have x times x, that gives us x squared. X times +9, that gives us plus 9x. -2 times x, -2x. And then -2 times 9 equals -18. I'm going to get these guys simplified. X squared, 9x and -2x combines to 7x. And then -18. And then we distribute this guy here, here, and here. And we get, I'll write it up here, x cubed plus 7x squared minus 18x. And that's exactly what we got in choice B. So let's go ahead and enter that, make sure we are correct. We are. All right, 2 questions left. These problems are in the slightly more advanced section of what's covered on the SAT. But even though it's technically more advanced math problems as far as like higher concepts, they're really not that bad. I think hopefully you can tell once you figure out the methodology. It's pretty straightforward. All right, let's see this. So what are its zeros? Again, this one's even easier than the last one. This one's nice. All you got to do is, just like we've been doing for each of these individual binomials, what's going to send it to 0? AKA, we set each one of these to 0. Right? How do we get x minus 7 to equal to 0? How do we get x plus 5 equal to 0? And how do we get 2x minus 3 equal to 0? Now we just solve each of these. Plus 7, x equals 7. That's 1, 0. A is out because it doesn't have a 7. C is out because it doesn't have a 7. We've already, just from 1, 0, we've already eliminated 2 answers. Pretty good. Then what about this guy? X equals 5. Let's x plus 5, sorry, equals 0. Subtract 5 from both sides. X equals negative 5. B has a negative 5. D has a negative 5. That doesn't help us. Finally, let's solve this guy. We add 3 to both sides, add 3 to both sides. Now we got 2x equals 3. Divide by 2, divide by 2. We got x equals 3 halves. 3 halves is not in B. It's only in D. That's it. It's pretty straightforward. So again, let's go ahead. What did I say it was? D? Yeah. Let's enter D. And again, guys, Instagram watchers, come to my YouTube channel so you can see these problems being solved. YouTube, search for Scalar Learning. All right. And number 5, this is the last problem of the day for these polynomial functions. Let's see. I didn't even get a chance to read it yet, so let's see how easy or hard it is. Okay. Yes, this is beautiful. This is, again, the same idea. Now, we're trying to find zeros. Now, remember, we're trying to figure out at which point are each one of these terms going to be sent to 0. Now, this is a constant up here. So we can't, there's no variable. There's no way to send that to 0. It's just 2. So we don't care about that. We only got x plus 55. We want to know what's going to make that go to 0. And x minus 17, what's going to make that go to 0. Let's solve for this guy. We got x equals negative 55. And then let's add 17. Add 17. We got x equals 17. Okay. So that's it, 17 and negative 55. And I think it's just A. This guy's out. Negative 17, that's wrong. They flip the signs. And this guy's not 3, 0. So that's it. It's just A. So that one's actually, again, the last two, I think we're a little faster, a little easier. Check the answer and we're good to go. All right. Let's stop the screen sharing. Okay, there you have it, guys. Hope that was helpful. Hope that was enjoyable. If you guys have any questions, always email me at huzaifa@scalarlearning.com. And don't forget to comment in the comments if you have questions. Subscribe if you want more of this stuff, more SAT, math, guidance in general, and to check out my math music videos as well. Thank you guys so much for joining, and I hope you have a great rest of your day. Take it easy on Instagram.